Hi there. Thank you for clicking on this video. In this lesson, we are going to introduce inverse functions, and I broke this into two parts. This first part is going to focus on the equations. If you are interested in learning about their graphs, that will be in a separate video. As always, please like and subscribe if you find this lesson helpful. Drop a comment or question to engage and let me know what you think, and check out the practice set for this lesson so that you can check your own understanding and reinforce the concepts that we cover. So first off, I wanted to talk about what are inverses. And there's lots of ways to look at and explore inverses. In my own classes, I have introduced them in different ways with different kinds of activities. In this lesson, we'll establish what inverses do and how we find them using equations. And as I mentioned before, in the next lesson, we'll explore how graphs of inverses are related. And then there's a couple more things that I might decide to do with them. So be sure that you're checking out the whole playlist that we have on general function topics. Hopefully you can find what you're looking for if this video isn't it. So the symbol for inverses, this can sometimes throw students for a loop because it looks like something that you've already learned and covered. If you're using Y notation, the symbol for an inverse will look like that. And you might be saying, that looks like an exponent of -1, like y to the -1st power. And indeed it does, except in this case, it means inverse. And so we might read that y inverse or the inverse of y. If you are dealing with function notation, the inverse symbol will go wedged in between the f and the of x. And so this you might read out loud like f inverse. You might read f inverse of x, or you might have the inverse of f of x. So there's like a lot of different ways that you could say that out loud. If you're dealing with the y, typically it would be y inverse, or maybe the inverse of y, if you're using the Y notation. So that is the symbol. Now, sometimes I'll ask my students, how on earth are you supposed to know the difference if you're looking at that, especially with the Y, there? How do you know if it's Y inverse or Y to the -1st power? And the answer to that is context. Just like in language, we have words that can mean more than one thing. In math, we have symbols that unfortunately can mean more than one thing, but the context around it lets us know what we're talking about. Just like in language, whether a word is like a verb or a noun, and so forth. And so that's how we can tell the difference. Now, I wanted to look at what inverses do. So before we get into how to find them, because I don't want any of my students or any of the people following me online to just be carrying out processes and not having any context or grounding in what those processes are. So we've got two circles there, and the first circle here is representing the domain of a function. Okay, and then we have the range. And if that seems really foreign to you, if you go back and look at some of my earlier videos where we cover like what functions are, they are like a mapping of from one set of numbers onto another set of numbers. And what a function does is a function pulls an element from the domain and maps it to an element in the range. So for instance, I'll just like we'll pick a simple function, okay, f of x equals 2x. We might pull a 3 from the domain, and that maps that 3 to a 6. And so it would look something like this. You take a 3 and you map it over to a 6. And so the function, like, it literally is like mapping a group of numbers from one to the other. Now, what the inverse will do is the inverse is actually going to take us in the other direction. And so the domain of the inverse is the range from the original function. And so what the inverse will do is the inverse will take that 6 and map it back to a 3. Okay, and so we could picture it this way. So I just used like a 3 and a 6 because I made up a function, but just hypothetically, if you have a 2, okay, the function might take that 2 and map it to a 3. The inverse is going to take the 3 and map it to a 2. More broadly, okay, the original function will take an x and map it to a y. Okay, so in this case, we had like x was equal to 3 and the y value was equal to 6. The inverse is going to take that y and map it back to an x. So that's what inverses do. They are functions that essentially undo each other in much the same way inverse operations undo each other. So adding and subtracting are inverse operations, meaning they undo each other. So you added 5 by accident, and you're like, I don't want to add 5. How do I undo that? Well, you would subtract 5. You would like take it away. And so inverse functions do that like on a broader sense. So you might have a much more complicated relationship, but they're going to do the same thing. They're going to undo each other. And once we can get our head around that, that actually leads us to how we might go about finding them. And if you focus down here where I'm circling in the lower right, essentially the inverse switches the positions of the x and the y. So what was an x is now a y. What was a y is now an x, and that gives us our clue as to how we might go about finding them. So general strategy here, how do we find inverses? Switch or swap x and y. This is swapping the domain and the range, okay? And what I usually tell my students is if it's given to you in f of x notation, take a quick second and just change that notation over. And now what you're going to do is literally switch the x and the y. So we've done this like swap of the domain and the range. If there is more than one x, okay, then you will end up with more than one y. And that can make the algebra step on part 2 much messier. We're not going to touch that in this lesson because this is an introduction. And typically you would see like messier ones in honors level classes, sometimes college algebra level classes, depending on your curriculum, like how messy they could get. But so if you had something like this, okay, we don't really want to go here, but x squared plus 2x, when you switch them, it would be y squared plus 2y. Okay, and we don't even want to go there in terms of solving it, but just to make the point there. All right, now once you've got them switched, now you're going to solve for y. And if you don't remember what that verbiage means, that means get the y by itself. Okay, and change the notation. So we want to make sure that once we get the y by itself, that we are changing it to appropriate inverse notation. So here we've got x plus 2y. Let's try that one more time. X equals 2y plus 3. So I'm going to go ahead and subtract 3 from both sides. So x minus 3 equals 2y. And then we'll divide both sides by 2. 2 divided by 2 is 1. And what I'm going to do when I go to rewrite this is I'm going to change that notation over. And that is equal to x minus 3 over 2, or, and I'm going to change 2 things up here just for variety, but you can go back to the f of x notation, and you can also split that up. And typically what I'll tell my students is there is no need to do this unless you are asked for it in slope-intercept form or want to graph it. It's a little bit easier to get the graph that way. But otherwise you can leave it like this and listen to your personal teacher's directions. If they are okay with you leaving it as y inverse, or if they want you to change it back to f of x notation if the original problem was. I generally, for my students, I do not care, but I do care if they leave off the inverse. Okay, so I am personally picky about that. Like, that is a notational thing that you need to have. Maybe your teacher's not as picky about that, as long as you get the function. Okay, so now let's see what these functions do. And I alluded to this introducing what inverse functions are, that they undo each other. So we can pick a number. We can literally pick any number. In my notes here, I picked a 3, but I feel like I picked a 3 earlier. I don't want to pick a 3 again. So like I can pick x is equal to -4, okay? So if I take that -4 and plug it into the function, 2 times -4 is -8, and -8 plus 3 is -5. Now over here, what I'm going to do is take that -5 and I'm going to plug it in for x in the inverse. So -5 minus 3 is -8, and -8 divided by 2 is -4. And lo and behold, look at that. The -4 turned to a -5, and the inverse took the -5 and brought it back to a -4. And we could do this with any numbers at all. So I'll pick one more number just for funsies. I am going to pick 1/2, just to show that this works with fractions. So 2 times 1/2 plus 3, 2 times 1/2 is 1, and 1 plus 3 is 4. And now I'm going to take that 4 and plug it into the inverse. So 4 minus 3 is 1, and like we're done. 1 divided by 2 is 1/2. So if you want to pause the video and say, I'm not sure, will this really work every single time? Like, go pick your own values, pick 0, pick like whatever you want. Go and pick that, and like I promise you, it is going to work for all numbers, because that's what inverses do. Inverses go back and undo the thing that you did. So sometimes the inverse of a function is not a function, and this gets like a little bit hard to wrap your head around. But if the original function is not what we call one-to-one, we're going to run into an issue. So I'm going to go ahead and we can kind of look at that. Y is equal to x squared. And here's where the problem is, okay? So I've got, let's see, we'll do 2 and -2. Okay, and here is my y is equal to x squared. When I square 2, I get 4, but when I square -2, I also get 4. Now, that's not a problem. This is not a problem for this function. Like that's still a function, because the definition of a function is every x maps to only one y, which is totally fine. Like each of those x's is only mapping to the 4. But we do have a problem when we go to reverse that, because now when I like do my little switcheroo, okay, now I've got 4. And the 4 is going to end up mapping to 2 and -2, and that is not a function. So what we might say, we could say the inverse is not a function, which is what I am more inclined to say, like that the inverse exists, but it is not a function. But you will hear questions all the times of, does the inverse function exist? And the phrasing of that, does the inverse function exist? They're using the word function in there. And so we would say, no, the inverse function does not exist, because it's not a function. Doesn't mean there's not a relationship there, but it's not a function. So the way like this would work is we would switch the x and the y. But then when we go to do the square root, we have to put this plus minus there. And that is one of those weird sticking points that often students will miss. I can use an illustration here. If you had y squared is equal to 25, okay, you might recognize, y could be either 5 or -5, that it can be both of those numbers when you square them. would give you the 25. And that's why when you're solving the equation this way, you've got to slap that plus or minus in front. And so we end up with y inverse is equal to plus or minus the square root of x. And now it's no longer 1-to-1 because whatever I plug in there for x, everything except a 0, I'm going to end up with two different numbers that map to it. So that is no longer a function. So that is like a slick little thing to just be aware of, that functions do need to be 1-to-1 in order to have inverse functions. Now, I am usually not in the market of trying to trip my students up with that, but in advanced classes or classes where you might be seeing this not for the first time, but you're seeing it for the second time. So it was introduced in an earlier class and now you're going back to it and you're going to take it deeper. Yes, absolutely. You can see those kinds of questions. Okay, so domain and range of inverses. I think these are interesting questions. So we already established that like when you're dealing with a function, okay, that the inverse is like switching that around so that the range of the original function becomes the domain of the inverse, and the domain of the original function is now the range of the inverse. So looking at this function, this is a square root function, and the domain of this function is x is greater than or equal to -2. Because I can plug a -2 in. -2 plus 2 is 0, and that's good. And anything bigger than a -2 is fine. But as soon as I go less than a -2, now I've got negatives under the square roots. So the domain of that is x is greater than or equal to -2, and my range is y is greater than or equal to 0. So let's see what happens when we find the inverse. So I'm going to do that little sub out of the notation. I switch the x and the y. Now I'm going to square both sides. So square, square, x squared is equal to y plus 2, and we'll subtract 2 from both sides. And last but not least, I want to change that notation over. So here's where it gets slick. That function there, that is a parabola that has been shifted down 2 units. Okay, that's got a transformation of 2 units on it. So lots of older material kind of coming back. If you are somebody who tends to forget absolutely everything that you did before, that could get very difficult for you here. All right, now here's the issue with that. That is not 1-to-1, and we just went over like, hey, if you've got a function that's not 1-to-1, it doesn't have an inverse function. And here's what we want to look at here. Right here, this was assuming all positive numbers, okay? Because when you take the square root, you're going to get a positive. Your y is greater than or equal to 0. This function here absolutely has to have a restriction on its domain. And how do I know what that restriction is going to be? Because I'm going to pull it from the original function. So the domain of the inverse is the range of the original. And so domain is x, and then what I'm going to do is pull that greater than or equal to 0 over. And then the range, we're going to pull from up here, and that'll be y is greater than or equal to -2. Now the range looks pretty good. If you look over here, okay, range greater than or equal to -2, so it's bottoming out. But that domain is a little sneaky, okay? It says x is greater than or equal to 0. So what that means is that the only part of this function that I want is it is, yeah, I do not want to pause the slide, so stop asking me if I want to do that. Is that part right there. And this part is not actually included. Okay, easiest way for you to do that is to go find the domain and range of the original function and just import those into the inverse. Now, sometimes you might be asked to do a problem in reverse. I don't think those problems are that common, where you might have to like work back from the inverse, like find the necessary restriction on the original function in order to make the inverse a function. I think that would be a less common type of question, and we're going to leave that alone for now. All right, so that is a wrap on that. Please don't forget to give this video a quick thumbs up. Subscribe to the channel for more math help, and give me some feedback in the comments. And check out the practice set. I will make sure that I link the practice set below so you can click right to it from here. And I hope to see you in a future video.